Okay. Equivalent fractions are fractions where even though there's going to be a different number in the numerator and denominator, when you compare the size of them, they're the same. And you might think, well, if they're different numbers, how can their size be the same? So I'm going to show you in two different ways, using a number line and using this like picture chart, okay? Kind of like a pie graph, how I took the pie and broke it apart. Now this first one, I have three different lines. And if you look, they're all the same length. They're actually 8 centimeters in length. I made sure to measure them to make sure they're the same length. And the first one I broke into two pieces, two fractional pieces, because they have to be equal, don't they? Each side, each piece has to be the same. Then I broke one down into 4 pieces. Then I broke one into 8 pieces. Okay. And the fraction that two fractions I'm going to look at are 3/4 and 6/8. Okay, 3/4 and 6/8. Now, so I'm going to look at these two lines right here, this one and this one, because this is the one that's broken up into 4 equal pieces. This is the one that's broken up into 8 equal pieces. Okay, I'm going to look at the first one, 3/4. So I'm going to come over to 3/4. I'm going to mark it right here. Whoosh. Okay, that's my 3/4. Then I'm going to go to my 8ths line. And how many 8ths? 6/8, don't I? 1, 2, 3, 4, 5, 6/8. And guess what? The lines are the same, aren't they? It comes all the way out to the same place. So this line is the same length as this line. That's what I mean by they're the same size. Okay? Okay, even though they're different numbers on the top and bottom, different numerators and denominators, when I take a line that's broken up into 3/4 and 6/8, the line's the same. So I'm going to come over here and look at this pie graph here. Okay, pie chart. The top one is broken up into 4 pieces, into fourths. And I went 3/4 of them. So I'm going to color in 3 pieces. 1, 2, 3. I'm going to color these at the same time. You guys see how much I have colored in? Okay. Now down here I'm going to color in 6 pieces. 1, 2, because I have 6/8. 1, 2, 3, 4, 5, 6. And look, I have these 2 pieces here, but don't these 2 pieces equal the same as this one piece that's left open? And these 3 pieces are the same as these 6 pieces. So see how even though I took the same size circle, I colored in 3/4 of one and 6/8 of the other. I colored in the same amount altogether, didn't I? If I took out all the lines and just left the shaded part here, they'd be the same. I could pick this circle up, put it on top of it, and the blue pieces that I shaded would overlap. They'd be the same size. So that's what I mean by equivalent fractions. The value is equal. The size is equal. Okay? Now when we do our... Yes, question?
Also cross multiply.
We're going to do that in a second, yeah. Okay? All right. Now, another way we can do this. Let's say I have 2/5 and 4/10. I want to know if they are equivalent fractions. Now, just like my man Brandon said, like he could come up here and teach this, he probably can. One way you can figure out if they are equivalent fractions, there's a couple of ways. Some of them are harder than others. We went over a pretty hard way during math class today. Another one is called cross multiplying. I multiply the denominator of one by the numerator of the other, the numerator of one by the denominator of the other, and see if they're the same. What is 2 times 10? What is 2 times 10?
5.
No. 2 times 10. 20. What is 5 times 4? 20. Are they the same?
Yep. Yes.
Guess what that makes these? Equivalent fractions. If I drew out this line, actually I am going to draw out this line. I'm going to make one 10 centimeters in length and break it down, and we're going to see that they are the same. So there's 10 centimeters. We're going to draw my line right here. And I'm going to make a line every centimeter. And then I'm going to make another one that's 10 centimeters. But this time, I'm going to break it into 5 equal parts. Do you guys see why I'm going to break one into 5 equal parts? Because it's my denominator. You see that? 5 equal parts. 1, 2, 3, 4, 5. Okay. Now, this first one, I'm going to go over 4/10. 1, 2, 3, 4. That's 4/10. And this first one is 2/5. 1/5, 2/5. Aren't they the same? They are, aren't they? Proves that by cross multiplying, we can get equivalent fractions. Okay, let's try another one. Okay. Let's try one that kind of looks a little messy even. Let's go 2/3 and 6/9. 2/3 and 6/9. Okay. See how these, I could just double this one and get 10. I can just take my 5, double it, and get 10. Oh, good. Now I can just double this top one. That's easy. Look, they kind of fit. But this one, I can't necessarily. Can't just double this one to get this one. Okay? But I can cross multiply. Two times 9 is 18. 3 times 6 is 18. Are they the same?
Yep.
Are they equivalent fractions?
Yes.
Yes. Okay. Yes.
You could triple it.
I could triple it, yeah. One thing that you can't do though on this, like another one that you really have to cross multiply, which is kind of equal to one of these, if I did 4/6 and 6/9, these are going to be equivalent fractions, but I can't just double it, triple it, or anything like that. I have to cross multiply. 9 times 4 is 36. 6 times 6 is 36. That's what I have. Okay? That's what I have. I want to do one more just to see. Okay. 4/9 and 2/5, because they're both just under a half. You guys see that they're just both under a. I wonder if they are the same. So who can tell me, how am I going to find out if they are equivalent? How am I going to find out if they are equivalent? Susan. Cross multiply. So Susan, what is 4 times 5? It's perfect, it's right. What is 9 times 2, Miss Harmon?
18.
18. Are they the same on the top and the bottom when we cross multiply? So are these equivalent? No! I'm even going to do the this whole thing right here, I'm going to go and not equivalent. Okay. So the easiest way when we have two fractions to tell is by cross multiplying. And the way we could check, we checked in the first few just to find out that math is true. We can use our number lines or our picture graphs, and we find out that they, when we do our cross multiplying, it gives us the right answer. And when we show it with the picture, we see how they are the same. Okay?